Now, let's see if that worked out okay. Looking good. Well, hell, that was a small amount of the technical difficulty solved. Fun times ahead there. The joyous nature of sitting saying, I will fire up my microphone. No, I won't. That's not going to work. Oh, no, it's all gone horribly wrong. So for a little while, we are going to be doing Turing Complete. Got a couple of levels still to do there. And we'll find out how we are going to go towards the tail end of the campaign. I think we have 3 more bits to do, hopefully, without having to rewire our hardware too much. Hello, Winsinger. How are you? You're sneaking with the first. Oh, yeah. Nicely done. How are things with yourself? All well? Not dead? Not on fire? Don't be dead. Don't be on fire. It's bad for you. Rule 0. Do not be on fire. Rule 1. Breathe in. Breathe out. Repeat. Like I say, we lost a lot of good people until that third line went in there. Could be better. Oh, slightly on fire. Singed? Or are we talking like, almost dead? How are things? It's not
second
good.
Place.
Hi, Michael.
Isn't that nice for you?
Yeah, second place is cool. Amy announcing there. These days, of course, you sit there and you say, oh, we'll have an AI voice. It's like, oh, it sounds like just a human. Why bother? Wow, let's get that sorted. Body fine, mind is nah. Yeah, okay. Getting rid of the brain weasels, is that the thing? Brain weasels gnawing on your cortex. I'll tell you what, pile into this lot. We'll have a big old distract, and you can be like, yeah, I have no idea what's going on. I can't think of weasels. I can just think of something else instead. Right. Here we go. Here we go. Yeah. And have you seen a medic if it's bad enough to be really worried about it? You're allowed to go see a doc and say, Doc, my brain is sick. It's much the same as going up and saying my ankles are sick or I've cut my finger. Yeah. Doing some stationeers. Oh, what you building today? What you building? Okay. We had the intern type out planet names in human script, and he forgot to capitalize each name. Okay. Cucumber heads are stupid. Inputs in this level represent the characters in a list of planet names encoded as ASCII. Alrighty. Each name is separated by a space, the numeric value 32. Replace the first letter in each word with its uppercase counterpart. That's really amazingly easy. Okay. Possible input characters are A to Z, lowercase, space, apostrophe, and oh, right. Okay. Well, here we go. Right. So, we are going to get an input that looks something like that, and we've got to output with capitalization. So, roughly, after every space, make the next letter capital. That's not too problematic, is it? What you wrote in chat, doc is not needed. Okay, right. Right, okay. So, sheer weight of traffic rather than, a single point disasters rather than actual systemic problems, shall we say. It's rough when that happens, it really is. Okay, now the manual, here we go, starts with ASCII encoding. There we go. We're going to expand that and make it louder, larger, louder, whatever. So, numbers, decimal, 0 to 7, so this is all in groups of 8. 32 is space. Now, there's something I know about ASCII which is quite entertaining. Capital A, 65. 1, 2, 3, 4 dots lower down. Lowercase a. Strangely enough, capital B, 4 dots lower down, lowercase b. This being divided into 8s, 4 dots lower down means 32. So take an uppercase A add 32 to it, and you'll get a lowercase a. Similarly, take a lowercase a, subtract 32, you'll get an uppercase a. And that will be true for all the letters of the alphabet. 1, 2, 3, 4, lowercase z to uppercase z. So the only number we really give a damn about is 32, one way or t'other. If it's equal to 32, it's a space, and we've got to think about what letter comes next. On that letter, we've got to subtract 32 from it. Another thing we can do, instead of subtracting, we can AND out that bit. So we can take 255 minus 32 and AND that in. Okay, glad to hear your mother's improving, Windsinger, because that's the kind of thing we really want. People getting better from their ills, rather than, getting worse. Right. So first thing I'm going to do, I'm going to vaguely cheat a little bit and copy some data in from previous programs. So my RAM pointer is 5, my program counter is 6, my in and out register is 7, my RAM value is 8. Let's actually call that RAM val. Really rough time during... Yeah, I can see that. It's, one of these things you don't know until you're there. You think, I'll be fine, I'll be okay. And then it's like, no, this has actually ripped my heart out through my chest and stamped on it on the floor. That's pretty rubbish. Ugh, awful. Right. So we are going to start with a loop. And we are going to... let's get this microphone out of the way. Add immediate to register. We're going to add 0 to register 7, which is our input, and store it in register 0, like that. Nice. So we've got our first character. Actually, I can go like that, can't I? Nice. Meanwhile, Winsinger's having first world problems. Opened a pack of chocolate milk, put it somewhere, can't find it. Oh, what a tool. So you've got like a box of chocolate milk somewhere in your house. Yeah, you're going to find that in a day or two, and you can definitely find it. And if the summer's nice and warm, you might find it in less than a day. But in between, it's going to be pungent. There's going to be pungentness. Yeah. If you wait long enough, it'll register to vote. Make sure you charge it rent. I see that this may well be the back end of it, Winsinger. Your brain is still slightly out to lunch. It's not 100%. It's the kind of thing that happens. Right. So, if I have pulled in a space.
Third place?
Oh,
what the heck were you thinking?
Aliana, how you doing?
Nah, I'm kidding. Third place is pretty damn cool.
Third place is damn awesome. Right. So it's not the character I have now that I want to give a damn whether it's a space. It's the character I had before. So if I cheat a little bit, const char is 0, const prev char is 1. Those are the registers I'm going to use. Nice. So, all right. I want to have my previous character in a register. Add immediate 0, 32 to prev char. Okay, so I pretend there's a space at the beginning of the sentence. Pretend space. Right, so the first character I pull in, branch not equal The moment you hear unwanted feedback, you'll know where it is. Oh, well, you reckon there's going to be like your chocolate milk just sitting in a corner saying, it's cold in here, I don't like it. Branch not equal, register and immediate. Previous char, 32. If it's not equal to 32, no change. Label, no change. This is really relatively easy. So we've taken the character in. It's in R0. No change. We want to send it straight out again. Add immediate register. 0 char to out. Nice. Then we want to store that. It's the amount of stuff you can get away with just an add with a 0 in one of the parameters. Wow. Once you start commenting on your MIPS code, oh mate, yeah, if someone is dissing your code, you sling them straight out of the house. It's like, I'm sorry, in the garden. Off you go. You go live in the garden now. Oh, okay, we're still in the fridge. Oh man, that ruins all the jokes. If you'd left it on a radiator, it'd be so much more fun. Right, so we're adding 0 from char, and we're storing it in prev char, and then back to loop. Right. Okay, so we've read in a character. If the previous character is not equal to 32, we're going to go to no change. That means there is a change here. And what we want to do at that point is knock off the 32-bit from our letter. So what we want there is... Right, so I'm going to do a little thing in hexadecimal. A bit of hex work here. Right, now 255 is F and F. So that's all 4 bits set at the bottom. 1, 2, 4, and 8. Brilliant. The next 4 bits at the top are 16, 32, 64, and 128. We want all of them set except the 32-bit. So we don't want to knock off the 1, which would change that from an F to an E. We do want to knock off the second bit, which would change that from an F to a D. There we go. So all the bits are set except 32. Okay, easy. So and register with immediate our current char anded with everything except 32 and put back into our current char. That was easy. That's pretty much it. That's the whole code. Okay. 32 is a capitalization trigger. It was empty space for some reason. Winsinger, joyously, it's both. Ooh. Yep, so the value of space, so if I say const space val 32. Space val. Space val. Right. As it goes, Winsinger, the bit 32 is the lowercase trigger. So if I hit the manual here again and pull up the ASCII table, so you see value 32 itself is space. But if I go to any letter, here's an A, and I add 32 to it, so add 8, 16, 24, 32, it goes to the lowercase version of the same letter. Plus 8, plus 16, plus 24, plus 32. So it's basically when you're in the alphabet area, which runs from 65 through to, there you go, 90. the next 32 along, 1, 2, 3, 4 lines down, is the lowercase version. When you're not between 65 and 90, anything could happen. Anything could happen. I mean, if I go to what? 49. 1, 2, 3, 4. It's a Q. 1 goes to Q. There's no 0. 1, 2, 3, 4 goes to P. There's a sneaky bit here that 48, joyously, is 0. So if you start with a 48, which is 32 plus 16, which means that your lower 4 bits can be used as a counter. In fact, your lower 3 bits, I think. Your lower 3 bits can be used to get yourself up to 8, and then onwards and upwards. Makes it a little easier. Somebody put the ASCII table together with a smidge of cleverness involved. Right, so let's go through the thingy then, shall we? Right. So register 1 is now equal to 32, so it's pretending that the previous character we sucked in is a space, meaning the first character in the line thinks it has had a space before it. So register 0. I should have put that as char. Oh, no matter. Is 118, which is presumably a V. Nice. It is not equal to space, so it should drop down to there and then get turned into an 86. Okay. Checking our manual. We've gone from 118, somewhere down here, 118, a lowercase v, up 4 lines, 1, 2, 3, 4, to an uppercase V. We're winning. Excellent. And then we stick that to the output. Off you go, mate. Dush. Remember it for next time, and then go back to the loop. So the next one we pull in is 111. 111. Wibbity bibbity boo. 111. An O. Excellent. Right, previous character in register 1, Bok, is 86, not a space. So it goes to no change and just kicks out the lowercase o. Chonk, chonk, chonk. Chonky, chonky, chonk. Vok. Voka. And then a U. And then the next one it pulls in should be a space. 32. Right. So if the previous character is a space, go no change. So it'll just kick out a space. But now the previous character in register 1 is indeed a space. So we're going to alter the next character, which is an lowercase a, 97. 97. I found it around here somewhere. It's hiding from me. 97, lowercase a, knock off 4 bits, should take us to 65. 65. Victory for the good guys. That's us, right? So off we go. Chonka, chonka, chonka. And it ignores anything that isn't basically the letter after a space. If it gives me a strange thing with an apostrophe as the first character, this is going to break. So I might need to put some clever in there. Or they're not giving me an apostrophe after a space for some reason, because they don't like their planets like that. Okay. There are some weird planet names here. Nice. And a few more to go. It's a nice bit of sensible software running here. Chunk, chunk. Seemed to end that one early. How weird. Chunk, 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 chunk. Still, off we go. Alrighty. Brief phone message. Right. Wow, it's worked. Taltopan is a Vulcan language from Star Trek. Don't ask you how you know that. That's harsh. I'm not supposed to ask you how you know enough about Vulcan. Am I supposed to say like Kapla or something? Because, you know, everyone speaks a little bit of Klingon. Ah, dear. That crack about the dogs in Stover Core. Oh, damn. Hello, Dota. Oh, hang on. I think we're on some lag now because that made no sound whatsoever. Let's try and see if I can...
Oh,
there we go.
hello, handsome.
Oh, bloody hell. Genuinely don't know. Just remember hearing it as Star Trek film. Okay, could happen. Right, what's the next one? Okay. Right. What's the next one here? We need you to help clean the basement. Move piles of radioactive discs from an old reactor. Oh, great. That's going to be top fun. Not sure to put a bigger disc on top of a smaller disc or the whole ship will blow up. Thank you for that. First 4 inputs in order. The highest disk number in the pile, 2 to 4. The source, which location number to move from. Destination, where to move the pile to. The third spot that is neither the source nor the destination. Right, okay. Move the crane with the following outputs. Oh, man. It's the name of the ritual used to restore Spock at the end of Search for Spock. Dude, you got some memory going on there. Ancient history.
Oh, hello,
Okay,
handsome.
bit of typing in the background to deal with the real world, and I will be back. Coffee. Thank you, Butts. I love a bit of coffee. And I love a bit of flattery. Yeah. Alright. Okay. Control the crane with the following outputs. 0, move the magnet to spot 0. Oh, here we go. Right. Play with the magnet manually by using the energy bear and enter to toggle. Alright, so... Dip, 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 dip. Right. Towers of alloy, huh? Alright. Okay. Dish. And this one is going to blow up the ship. Boom! Everybody died. Press reset to try again. Okay. Dish. So, don't screw up, all right? Chunk, chunk, chunk. Oh, great. Right, 1, 2, 0, 1, 2, and 5 to toggle the magnet on or off. All right, okay. Okay. Play with the magnet manually. Oh, blimey. Well, wow, they've given us a whole algorithm to play with here. Interesting. Implement the following algorithm. Function move, disk number, source, destination, and spare. If disk number is 0, move disk from source to destination. All right. Otherwise, call move again. So this is recursive. Disk number -1, source, spare, destination. Ooh, subtle. Move disk from source to destination. Which disk? Whatever. Okay, fine. Move disk number -1 from spare to destination to source. All right, so that's all. So that's a function call. That isn't a function call. That is a function call. Wow, can I copy that text? No. Fine. So I've got to write a move function which contains this gubbins here. Shouldn't be a problem. You know. Yeah. Yeah. All right. Go on. The real world is kicking my butt today. Yeah. All right. Right, back to the plot. Okay. Sorry, I'm being terribly distracted. Right. What's happening in the real world? It's nothing heavy. It's a bit heavy, but not fatal. Just arranging business. And kicking my butt is more sort of busy than I'm sitting there dying horribly. First world problems, shall we say? Let's go with that. Right. So.
Coffee.
Thank you very much. Kumakwa. I salute you with my cup of coffee. Indeed. And Butts, thank you. I may take you up on that at some point, but hopefully I shan't need to. Right. So, first 4 inputs. The following in order. Right. Actually, let's go back to our previous one as well, like we often do, and pinch the register numbers out of it. Off we go again. Yeah, you can shut up. Right. So we're going to pull in our first get input data. Add immediate register, and what are we going to do? We've got Wow, we've got 4 registers entirely that we can use as source information. How am I this evening? I'm okay. I'm holding it together. I've had better days, I've had worse. But you know, life is mostly sweet. But yeah, busy is better than bored. But you know, I'd rather be relaxing, happy than running around like a blue-assed fly, and I'd rather be running around like a blue-assed fly than staring at the wall going, I hate this, it's dull. And Kamakwa saluting me with a smoothie. Ooh, what you got in the smoothie? Is it tasty? Is it yummy? Right, we'll add a 0 to our input. And we'll store it in register 0. And that's... We're going to... the highest disk in the number. Highest disk. Disk. Right. 0 to input. I'll put that in 1. Yeah. Right. Source. Add IR0 in 2. Dest. Add IR0 in 3, and we'll call that spare. Okay, nice. Nothing fancy. Orange juice with frozen strawberry and mango. Oh my, that sounds tasty and very, very healthy. Very healthy. Terribly healthy. Yeah. Okay. Right. So, put some comment line in here. Output 0, 1, 2, move magnet. 5, toggle. All right. How hot is it out there, Kamakwa? Is it toasty warm at the moment? Right. Label. Stop. Just in case. Label move. So, I'm going to do some pushing and popping, aren't I? There is definitely going to be some pushy poppy business going on here. So I'm going to have to implement the concept of function calls. So the first one here, disk number, source, destination, spare. So add immediate register 0 to if I push them in that order, I must pop them in the reverse order. Okay, that's doable. Do I... Okay, I've got BSR written already. Branch to subroutine. That's cool. I'll remember how to do my my returns as well. So I believe I was using a straight add immediate register 0 stack value to program counter, and that should give me a return. I'm going to vaguely cheat and go to a previous thing. Last week was 28 to 31 degrees C. Ooh, blimey. This week, a lovely 18 degrees with a sea breeze. I could work with that. That sounds toasty. So, robot racing. Did I actually use subroutines in that? Can't remember. No, I just hard-coded the whole bloody thing. But, there we go. Did use some subroutines. Okay, fine. Alright. Back here. Yeah. Whatever. Right. So, if we push our stack values, so add IR, immediate 0 to register 0, to stack value. So that's a push, I hope. Yeah. Right. So that's push highest. Add IR 0 to register 1. Stack value, push source. Add IR 0 2, stack value. See, I could. Why am I even doing this? Look at that. I could just go like this. Straight from the input to the stack, because my architecture should let me do that. This is going to be a laugh. Right. So now I need to pop them back again. I'm going to need this anyway. Oh, whatever. 0, 1, 2. This is a pop. Pop dest. Det. I don't know. And 3 pop spare. So the function we are supposed to be implementing is this fella here. So if disk number is 0, right. BQ IR. Alright, BQRI, fine. Register 0 is equal to 0. I'll call this move disk. I'll go down here. Label move disk. Disk. And then, right. Move disk. Actually, did I put that? I made BNESR. Did I make BQSR? I didn't. Let's have a look, see if I can do that. So 113, that means my 32-bit is my return, I think. Might not be. Yeah, BNERI. Where have I got my BQ? BQRI. If I change that to that's BQSR, RI. Brilliant. Branch if equal subroutine. So a bit more stacky goodness going on here. Fun times. Right. BQ. Oof. Yeah. So we're going to make move disk, which is output, add immediate register from my source to my destination. So I add a 0 to my source, which is register 1, and that goes to out. And then add immediate, because I just want to go 0 and 5 to out to turn the magnet on. Move to source. Magnet on. Add immediate register 0, 2 to out. Move to dest. And magnet off.
Coffee.
Thank you, LV. How you doing?
Coffee.
Running low on this one. Gonna have to get another fairly soon. All right. So nice. So that's returned from the function. Yeah, I don't want that. I don't want that at all. But it is useful. I can do a sneaky thing with it. So we're doing a deliberate jump to move disk, which will go there and then bang out from where we're going. If register 0, our highest source, our highest disk is 0. So the next one, I need to copy this lot. I know.
Coffee.
Oh, more coffee from Delethea. Hurrah! Thank you.
Coffee.
Yeah, really am running low. One more smidge probably in there. Right. Push. So now this is going to be fun because I'm not entirely sure these are going to be in the same order. So I'm going to have to be careful. Right. So I am pushing disk number -1, which is my highest. So I actually want to sub IR here. Sub IR. I want to subtract 1 from my highest thing and leave that in the stack value. That's cool. This coffee was bought by the letter Q with the number 00101010. So that would be 0 down to 60, a lowercase. 2, 4, and 10. 1, 2, 4, and 8. Lowercase 10. Yeah, that's not a proper letter. It's not a letter. You've got me confused on that. That's value 42. That is 42. Right. So the source. I'm gonna have to reverse these at some point, aren't I? Right. this wants to be in reverse order because the way the pushing and the popping goes. Or this wants to be in reverse order. Let's make this in reverse order. Because it's easier to deal with. Uh-oh. Right. Okay. It's a number. It's a number. It's true. It's a good number as well. It is quite delightful. So, disk number -1, done that. Source spare, ooh. And then destination, or spare destination. All right. Then BSR move disk, which will bop in, bop out again, which I'm hoping will still eat the 4 numbers that we've got in here. Those shouldn't have changed. And then, if they've explained their algorithm right, this should work. Right. Disk number -1. Yeah. Spare first. And then destination, and then source. Well, interesting times. And then we branch subroutine to move, which is what we're doing. And then we do a return at the end. Okay. Yeah. Right. Okay, so let's see how we go. Start. Right at the beginning. Well, that's not going to work at all because I haven't done that. Right. And we need to find our stack, which is this fella here, I think. Yeah. Right. So, numbers. 4 disks from .0 to .1 using .2 as a spare. Alrighty. I've just realised that's not going to work either because I have to remember to do those because we're always a 4-byte instruction set. Alright. Try again. Dart 4012. BSR to move, which has pushed 20 onto our stack to say that our next return line is there. That's cool. So my registers now, which I can see here, I should be hopping oh, that's not really right, is it? Look at that. I've pushed my registers on here before I went in. What a mess. Yeah, I got that right back to front, didn't I? I need to put I can't put my registers into the stack before I start. Oh no. Yeah, I need my values in registers as I hit here, and then I push them in the stack in there, and then do a call. Is that right? Yeah, I save my registers on the stack, do my internal work, and then pop them back off again. Because what I'm going to do right now is I'm going to pop this into register 3, and it's going to get me 20, which is not what I want. Or, in fact, it's not. Okay. What the hell? What have I got in register 3? 0. 1 in register 2, and 4 in register 0. Okay, well, the numbers are good, mostly. Mostly. Oh dear. We got more bots again, but that's not what we want. Yeah, this is nonsense. I've written a complete nonsense here. Damn it. Damn it. 0, 1, 2, and 3. Right. So, first job. Push my values. Last job, pop them back again once I've finished. Account created yesterday in 10,000 channels. Yeah, that sounds vaguely like one of them bots that we speak of, isn't it? Right. Okay. What's that old bot emote? I don't even know. Which one are you talking about there, Delethea? Right. So, if our highest is 0, jump to move disk, which is here. And then we're going to return. Okay, right. So once we've returned, we actually want to pop our values back again into the registers that we had them in. Flump. Label, leave. Pop, 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 pop. But because we pushed them in a certain order, we need to pop them in reverse order. 0, 1, 3, and 2. No. 0, 1, 2, 3. Okay, that's fine. Going up. Oh dear, the one that gets green and could have been on the Jetsons. That sounds like the fella, doesn't it? Right. Okay, so if disk is 0, move disk. Otherwise, sub immediate register 1 from register 0, leave it in register 0. Oh, actually, let's leave that in register 4. One less disk. Alright. Yay, But's got it. Cool. Right, and we need the algorithm back again because my brain is now frying gently. Alright, and we need to move the parameters around. That's going to be a giggle, isn't it? So, source, spare, and destination. I must be doing this wrong. Definitely something ain't right. Because it felt right to push my parameters and then my return address. But I really want to push my return address and then my parameters. So I could do that. I could deliberately push a return address and then just jump. God, and then with the return at the back end of it, that might even work. So I'm going back and forth here, back and forth like a mad beast. All right, so let us pretend. I push a return address onto the stack. I push a parameter set in order, bop, 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 bop. Get to the function, pull off the parameters, bop, 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 bop. And then I know that my return address is waiting for me there. That is actually the right way to do it. So my function call concept is literally just write a value to the stack pointer, not the stack pointer, the stack value. Oh God, right, here we go. Wow. Right, so first job, it's not BSR move. First job, get input data, add immediate, because it's going to be an actual value. I move to stack value, so that should push return address. Parameters written to stack value, and then jump to move, because I don't care if it's a subroutine or not. I've already pushed my return address. Okay, looking good. Right. So we then pop this lot off. Derp. Who mailed you something that you desperately need a return address? Some tax agency? Yeah, normally. Yeah. DVLA, the Driver and Vehicle Licensing Agency or whatever. They want to find out how many wheels I've got in my house. Something like that. Right. Okay. Nice. So, I have not done that, right? 3, 2, 1, 0. Get rid of those and pop them again if I need them. Depends how much broader definition of wheel they have. Oh my. Oh goodness, yes. They get a little weird every so often. They really do. Right. So, if I call this bunch of stuff to the outs, doesn't change the stack shit at all, and then calls a return. That is how we want it. We subtract 1 from register 0. We do not do that. We pull this here. Right, this whole chunk is effectively a function call now. Right. Push the return address, because we're calling move. So this is actually sub IR. Subtract 1 from register 0 for our highest disk. 1, 2, 3. What's going on there? Right. A definition of inner house. Ooh, that's a good one, Butts. I could probably work with that. I could define my living space as a small cupboard in the corner and the rest of it's just outbuildings. That would work. Right, so first chunk, if disk number is 0, move one disk, chunk, move disk number. Now I want source spare destination. So source spare destination. Off you go. Jump to move, where you will pop it out in the right numbers and do the thing and carry on. Right. Then we move disk from source to destination. I can use BSR at this point because I'm not changing any of my numbers. I'm not changing my stack. I'm just going to do a thing and come straight back again. Nice. And then I very nearly want to do the same again. Okay. Chunk. So push my return address. Subtract 1 from the highest disk. And this time is pushing spare destination source. Spare destination source. All right. And then we are done. Blimey. Let's see what we've got now then. Alright, so first job. Push the return address of move. 26. Nice. Get. Ooh. Wow. Well, that didn't work. That did not work. That did not work. It did not work. Not working. So add IR, and that did the thing. Leaving something in there. Why do I not?
Oh
my. Yeah, something ain't right here at all. Is it not working because I haven't sent it an aardvark? Could happen. Do it, no. I'm trying to work out why I've got a 255 in here. Why are you hot? I shouldn't be. I should be adding 1 to my stack register. Why are you hot? You're the right value there. You 26. But this is an immediate number. Why do you care what that is? Is it 26 immediate? It's immediate, was it? Ooh. Why are we caring about this here register? And the purple is correct. What have I got wrong? So I've actually got a hardware error. Oh no. One man. Oh yeah, confuzzling in a big style. I mean, this is like, some proper kind of brain screw up kind of shizzle. Alright. So something is not right. It's wrong. It's broken. So, my immediate numbers, 64 and 128, really should also have similar OR gate functions around on my register select, because if I'm pulling an immediate number, I do not want any of my register lines hot. Well then. Was there an aardvark involved? Is that a programming term? No. Not that I know of. However, it's a possibility. Right. So.
Oh, yeah.
Hey, Barbaric,
Hot
how you
register
doing?
lines in your area. Click to learn more.
Oh, yeah. Proper hot register lines as well. Really quite toasty. Thank you for that sub there, dear chum. 2 months, that's like 1/6 of a lap, something like 150 million miles. Nice to have you with us. And always wonderful to have excellent chums around. Right, so this line here, denoting that my instruction is an immediate. So that's going into 192. It hasn't actually lit anything up yet because I've stopped the process. If I go like that, this one should effectively be disabling all my register lines here. So I want to need the OR gate to say if this line or that line are very warm. Lovely. Tonk. You can go there. Right. And you, oh matron. How are these different? Yes, these are different. Alright, you can sod off for a moment. Sod off. And you, come here, all of you lot. Drop down by chonk 1. Gonna need to do that here as well, but irritatingly, this line is in the way. Aren't you just annoying? So I'm gonna have to move. My registers will no longer be symmetrical. What will I do? I'll just cope. I'll just be like, yeah, whatever. Right. Here we go. You can move down. And no, you can't move down yet. You can move down first. No, you can't. I've got to get you. Oh, everybody's got to carefully move in the right order, or you end up welding a bunch of stuff together that will really make life miserable. I mean, astonishingly miserable. Missed. Try again. Right. And then this lot. Chonk. Okay. Done. Dusted. Whew. Trickiest thing one man has ever set up: a 7 days to die horde base with a bunch of electrical traps. That's pretty butch. That's not bad. No one's going to tell you that's rubbish. Well, if they do, they're a lying sack of shit. So that's also cool. Right, you Doc. Still something ain't right. Do you need to move down one more? You do, don't you? You need to move one more down just to annoy me. Fine. Alright, we're doing it. Cards above. Chunk. Chunk, chunk, like that. Alrighty. And you guys, there we go. That's fine. Still fine. Everything's fine. Chunk. No, everything should be fine here. What's the problem? What do you cause? Why are you causing me fuss? Alright, you're causing me fuss because you do actually all need to move one more down. Right, okay. Just to give me room to maneuver. Come on. There, 1 and 2. Alright. Okay, we're doing it. Ever played 7 Days to Die? Yeah, a little bit. Little bit. Now and again, I have done the old 7 days thing. I have built many a base, horde and otherwise. Grinned like a ninny at a bunch of zombies coming in and then gone, oh, police. Whoop, whoop, that's the sound of the police. Right, so my grey line is the middle one there. So we'll go up to that point. And that point like that. Okay. So if I then stop that, tick that. 192 should be coming in. 192 should have warmed up. $64 and 32 there. Oh, have I got these upside down? Do I need a knot in there? Yeah, I really do, don't I? I need a knot on this line. Chunk. Doop. Righto. Okay, that's not too problematic. Oh, we've had one more down. Can you get an 11sies? Yeah, probably. 11. Are you sure you don't want second breakfast instead, Delethea? Second breakfast is a good call. And it's one of those things you look at and think, yeah, why is this just not a little bit more normal in the world? All right. One more line there. And that one links to here. And another knot to invert them. Okay. What a mess. What a mess. Now, could I... See, I've got inverters there, and I've got inverters here. I could actually just put those two inverters in there and save myself a few gates. Right. Ooh. Join you two together. Right, that's more like it. Brilliant. That feels a lot nicer. And just as functional. Woohoo! A21 due. Yeah. I've been having a ponder. I mean, some chums and myself fired it up again for A20. Rampage through because, you know, we've been here before. I mean, we won the apocalypse in about 80 days. To the point where we were doing mad things like making 1/5 scale models of the Pyramid of Cheops, but in a Las Vegas style. Seemed like a good idea at the time. Not sure it was, but, you know. Right. Yeah, we had the whole thing faced in black marble. There was a maze underneath and little things pretending to be slot machines. Because you can. Right, let's try this again, shall we? Stop that. Up here. Get the assembly code up and move down to the RAM block. Whoa! What happened there? Oof. Blimey. Okay, everything went horribly wrong. Horribly wrong. I'll zoom in on our RAM, which is this. This is our stack. Okay. Sideways. Sideways. Stop the world. Time to spam crawlers in Mechabellum. Ooh. I do not understand. You said words. I understand spam. I do not understand crawlers well, and I do not understand Mechabellum at all, apart from I'm kind of guessing it's a game. Right. So, push 26. Nice. Alright, 1 is in here, not 255, so it hasn't decided it's a pull instruction rather than a push. So 4 for the highest disk, 0 for the source, 1 for the destination, and 2 for the spare. Jump to move. Honk. Right, into our registers now. Pop, 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 pop. So, well, that ain't right. Register 3 is 2, as expected. Nice. Register 2 is 1, as expected. Register 1 is 0, as expected. Register 0 is 254, because I'm an idiot. And that's what I should have done. Okay. And all of those are bust. And that is why you run it through the debugger before you ever do your actual code. Don't let the thing run. No, because, oh god, the horror. You step through it bitty by bitty and cross your fingers that you haven't made some kind of radical mistake, especially when you're working with hardware. When you're working with something like, little robot arms that go up a bit, light a bit, you don't go, no, fuck it, it'll be fine. You move it one step at a time and the arm goes zzz, and you go, it'll move up a bit and it zzz, now move down a bit. Shit. Yeah. Bang, hit the big red button. Okay, let's try again. Alrighty. So, 26, 4, 0, 1, 2. And in my registers, we're going to jump to move. There we go. 2, 0, 1, 4. Alrighty. Nice. BQRI to move disk. No, we do not want to move disk. Ooh. May have made a mistake here as well, because I've subtracted 1 from my highest disk and I've left it in my highest disk value, which I've then passed across, which is fine. But then I've moved my disk. And I think, given the algorithm, I don't want disk -1, I want disk qua disk. So I'm going to put that into there, and there, and there. Alrighty, let's try that again. Derp, 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 derp. Hamina, 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 hamina. These are technical terms, by the way. You should keep up. All right. So in register 4, we should now have 3, but we've got 253. Sub IR. So I've got that wrong. So I've subtracted 4 from 1. Well, that's just annoying. Sub RI 0 1. Try again. And in register 4 I get a 3. Good, that's how we like it. Push the return address. Push some more numbers. 4. Ooh. Egypt. Could I just go... I don't need register 4 in there. Could I just subtract 1? Yeah, I should have done that. That's what I should have done. Doesn't matter, doing it this way now. Right, we'll try it in a bit in a second. Push return address, which is still move. 3 0 source spare destination. Jump to move, which is at the top here. So we pull those out into our registers. Pop, 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 pop. Still not on 0. So 1 less disk into register 4 is 2. How many? Pop those back out. Still not on 0. 1 less disk in the register 7. I'm not sure this is right because I've left no parameters in here. Left no parameters at all. So what's going to happen is I'm going to come up back in here and my registers are not going to be what they were. It's going to be a bunch of nonsense and nothing. Done it wrong again. Pushed my return address. Nice. Pushed my parameters. Popped my parameters off. Pushed my return address. Pushed my parameters as altered. And on we go. So should I have left my parameters on the stack until my return is there? Hey Dweller, how you doing? I'm playing fun with stacks here.
Let the feast begin.
Feasting time, says Dweller, and feasting time it is. Today I have, on my delightful warmer, I have hot noogs from Best Beloved.
Coffee.
And I think I'm just about to run out of coffee as it goes. I've got more noodles. Oh, spicy. Thank you very much. Spicy noogs. Now then. Problem. Still causing me bother in my head. If I hit a subroutine, mid-game, so didn't respond. Mechabellum is a mech auto battle game. Oh, kill, maim, destroy with rockets and kaboom. That's what you want. Definitely so. Right, so push a block of parameters on the stack. I push a return address. When I get to the function, I pop a bunch of parameters off the stack. This is cool. When I then jump to a new subroutine, do I have to push my previous... push my previous parameters to remember them for later? Well, they don't stay in... They don't stay in the registers unless I do that, I suppose. So what am I doing wrong here? I know what I'm doing wrong. I'm being an absolute frickin' ninny is what I'm being. Wow. I don't want to be popping my parameters at all. I've got them in the registers. I should be leaving them in the registers. And pushing them when I jump to a new function, and then popping them back again when I return. No, that can't be right. That's just weird. Doing it wrong somewhere. And this feels right. Push your parameters, push your return address. Kumakwa, have a lovely time. I will do my level best to have a good stream, although I have a suspicion my head is actually going to fall out on the floor at some point. It's just kind of weird. All right. So what are we talking here? If I have my parameters in registers, I arrive at my function, I can push them, save them on the stack. When I leave my function, I pop them. Just to save the... Yeah, all right, let's do it like that then. Change everything around again. No, 1, 2, 3. So as soon as we arrive, push 0, 1, 2, 3 in that order. That's cool. BQRI SR subroutine, because we can, to move disk. So that will move disk, come straight back. I can sub IR. Is it RI? RI, sub RI. Oh, let's leave that in 0. The rest of you are left the same, except I need to move them around. I need to change my parameters about a bit, so that's slightly inconvenient. Right. Oh, another one. Thank you, Butts. You're doing fine work there. Right, so my parameters are in registers. So I want to be passing.
Let the feast
More feasting.
begin.
Thank you, Bots. I will have more feast. Heading off too. I will have a good stream as best I can. Thank you very much for hanging with me. I know this is a little on the frustrating side. Everybody looking and going, "You're doing it wrong." But I will get it. I will get there. I've been challenged before the whole human race, and I ain't going to lose. Give Snow my best regards. Okay, so sources in register 1. Destination in register 2, spare in register 3. So right now, I need to swap stuff around and then call my function accordingly. Oh, this is going to be icky. Lot of swapping stuff about. So I need to move destination to spare and spare to destination. Those got to swap over. And then they've all got to swap around a bit just to mess me up. Can I do this with some shenanigans? Kind of can. I can push them onto the stack and then pop them off in a different order. So let's do that. A bit mank, but we can do it. Got to be a better way of doing this. There really has. Parameters should come in on the stack. They really should. Oh well, no matter. It's got some horrible methodology error in my head. So, source remains the same, so that can just stay. I want spare pushed to the. I want destination pushed first, and then spare, and then SV goes to 3, and then 2. This is going to be messy. It's 4 lines where I could do it in 3. Probably be a little more careful. All right. So, destination is 2. We'll move that to 4. We'll then move 3 to 2. And then move 4 to 3. Right. Swap reg. I don't have a swap reg. Damn it, I need that spare register to store my original disk value in. Oh. Maybe I should be using my RAM instead. Yeah, all right. Do it the 4-line way. Right. Add IR 0, 0, 4. Save the disk val. This is tacky. I don't like it. Add IR 040. We're back to where we were before. Move disk. Right. One less disk. Well, that is absolutely nonsense. We do we want to pop. I hate myself. I hate everything. Don't hate myself, really. This is too messy. I've gone back and forth twice now. I'm probably going to go back and forth another time as well. Right. If I put my parameters on the stack, call my move, semi-prime, don't be too hard on yourself. You've got to be doing one of the hardest things you could possibly do in a video game. Should be able to do this in real life as well. But okay. So, everything's fine. Parameters on the stack, return address below the parameters. Hit the function, pop off all the parameters, blah, blah, blah. Very nice. I then want to, whenever I call another function, I want to push my registers again. And on return, I want to pop them. So do I need to push and pop around every call? I might need to. I might just be the way. It might just be just a lot of extra pushing and popping. Alright. Undo is my friend. See if I can get it to the right place. Well, that's not too bad. Alright. Okay, so my parameters are on the stack in order of this. This is the push order. We jump to move. We pop our parameters off the stack. Nice. Pop our parameters off the stack. I didn't quite get to where I wanted to be, but hey, whatever. And I'll cut that out for now, but we'll probably be back here in a little while. Parameters pop off the stack. Call move disk, and then we're done. We're back out of this routine. We are returning, because move disk has a return at the back end, which will go straight to the top. So if it's one disk, it'll move it, then it's done. Right. So, one less disk. Nice. And then we want to push our own parameters to save them for later. Then a set to do a call function call with. Then we do the function call, it comes back, and we pop our own parameters back again. Okay. Right. So there's going to be a pushy bit up here. Right. Function call. So the function call looks like that, but with some slightly different parameters in it. But that's not important right now. First job. Save our registers. Function call. Retrieve registers. Retrieve. That'll do. So, 0, 1, 2, and 3. Not gonna bother with the function call yet. Gonna just save and retrieve my registers. I'm doing it. Here we go. Alright. 3, 2, 1, 0. Alright. Nice. Save registers, function call, retrieve registers. Excellent. Right. Now we're going to do this again. In a bit. So chunk. All of you look, fuck off. It's fine. Go away. Right. So, function call. Return address. Highest disk. Sub RI, because that's how it works. 1 from our highest disk. Sub RI. And stick it in the stack pointer. 1, 2, 3, 4, because that's our push order. No. 1, 2, 3. Right, so our push order for function calls, there, highest source dest spare. Right. Excellent. But because this function call is a sneaky one, we want source, spare, and then dest. So we're actually going to swap those over. Oh, such sneakiness. Push those. Those will get popped off, poppity pop, when we hit our function. Brilliant. Nice. Then we do VSR move disk. And then we do all of this shenanigans again. Copy. Paste. Save our registers. Have a now. Function call. 1 off the highest disk. Nice. Then spare. Then destination. Then source. Function call. Retrieve our registers. And bang out. Do we need to retrieve them after that? I don't think we do. can I get away without a save and retrieve after the last function call? Because I don't care anymore. Am I going to leave my stack unbalanced? I am not. Right. I can actually ignore this last block because we don't give a toss. We are returning at that point. Alrighty, off we go again. So, line 1. Stacky goodness. Right. Okay. 26. 4012. We're kind of getting used to those numbers now. Register 3. Should have a 2 in it. Doesn't. Why doesn't it? Register 3 has a 0 in it. Because I'm an idiot, that's why. I haven't actually made a pop at that point, I've made a push. Three, two, 1, 0. Right. Save our registers. Function call. Retrieve registers. God, this should not have been this hard. Should have been a piece of piss. I mean, let's face it, I've been doing this for, what, 35 years? Ooh. Right. Oh, we need that bit on the end. You go away. Oh, no, you can't. Right. Off we go again. Hammer, 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 hammer. Right. So, register 3 has a 2 in it, register 2 has a 1 in it, register 1 has a 0, and register... God damn it, I did it again. I did it again. Okay. Pop parameters. Nice. Check. Move disk. And we've got a deliberate jump in there because it's got a return on the end. Yeah. Yeah. Right. Let's try that again. Off we go. No. 4210. Why has register 4 got anything in it at all? It's just, no, just stop. Stop it. You're embarrassing yourself now. Right. Okay, 4 0 1 2. 4 0 1 2. Good. Is it a 0? No. Save our registers. Push them back onto the stack. 4, 0, 1, 2. Function call. Right, so that should put 3 onto the stack. But appears to have put 0 onto the stack. Sub RI. Oh, yeah. Derp. Okay, yeah. Register values and your actual values correct. And round we go again. Right. Return address 3. Our register 0 still retains a 4 in it, which is nice because it should. 0, 2, 1. Jump to move. Pop, 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 pop. Move disk. I put the highest disk in as the... Ah, man, yeah. If I'd done this the other way around, I could have got away with 1 pop and push. Oh, well, whatever. Done it that way now. Right. Save our own registers back. Put a thing. 2. Right. Jump to move. Pop, 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 pop. Still not on 0. 2, 0, 1, 0. Return address is now jump to move. Grab, 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 grab. All right, register 0 is still now 1, so we're still not there. Jump to move. Pop, 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 pop. Register 0 is now 0, so we jump to move disk. Right. I said we jump to move disk. Why don't we jump to move disk? EQRI move disk. Where's my bloody... Oh, right, it's working. Okay. We're down here. Magnet on. Which is source. Move to destination. Magnet off. Nice. We've actually done something. Return. Now. Okay. So I've just realised that's this function call here is a bunch of mank because I don't want my return address to be there, do I? I want it to be here. I want it to be just after this one. So what I actually want is add register immediate add IR 4 bytes PC SV, like, yeah, push return address of the next thing, which is what I should have done, but I did not. Screwed up. Right, try again. Add IR 4 bytes to the program counter. Damn it. This is some freaking tricky shit, man. It's melting my brain. Ah. Okay, so when we get down to here, eventually. Right, 26. 66. Just right. Excellent. Okay. So we've pushed 66. We've saved our parameters, and we're going to keep going down. No. 66 again, that's correct. One more go round. And right, register 0 is 0. So now pick the thing up, drop it, and bang out to wherever we were before. So that should have come back to somewhere down here. All right. Oof. Okay. All right, so we've come back to 66. Okay. Sub RI highest. I don't like the 255 on the stack. I don't like that at all. Oh, mate. No, I don't want to be pushing that, do I? I want to be pushing here. Gods. 4, 8, 12, 16, 20. The point after my function call has gone off. Alright. 4, 8, 12, 16, 20 again. This is why I never got into writing compilers. And well, okay, there's lots of reasons why I never got into writing compilers. Okay, and off we go. Pick up the disk, move it, drop it. Return to 82. Did I do that wrong? Does it come in here? Okay. So it's not actually 24, because that's just going to straight back to move. All right, 24. Off we go again. Hammer, hammer, hammer. Jesus H, tap dancing Christ. All right, register at 0. So move the disk, drop it, return back to 86. Pull in our parameters as they were. Chunk, 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 chunk. Oh, that does not look right. Oh no, it does. Yeah, because we're n levels deep in the bloody guts of the thing now. Right. So move disk. Ha. Good start. Back here again. Highest disk pushed as a 3, now a 0 again, because we're deep in the guts of it again. And then we jump to move. up the top. And we pull our registers in. And we go and move the disk. Ooh, now there's a thing. I say, matron. Boom. Everybody died. Right, so it started working. So what was the problem here? What have I implemented poorly? 0. So 1. I did a thing, Guntar, and it was looking good. It was looking briefly exactly how things should be. Alright. Alright. Okay, so where are we now? We've just we've switched the magnet off, and we've come back to here. Right, so that looked good. So that's where we are. Retrieve our registers. What do? We pushed highest, source, destination, and spare. We're pulling spare, destination, source, and highest. And that's cool. So move to source. Magnet on, move to destination, magnet off. So that worked. Right. Subtract. Right, 130 is our return address over here. Let's maneuver that a smidge so we can see all of the bloody thing. Subtract 1 from register 0. Register 0 is 2, so we should be pushing a 1. Why are we pushing a 0? Sub RI 1 0 to the stack value. Now I've got a confuse on. Sub RI. That worked last time. Why does it not work this time? Register 0 has a 2 in it. Why am I got a different value? Register 3 has a 2 in it. That got pushed fine. Twisting my melon, man. Twisting my melon. Have I changed register 0 in here? Not on purpose. Everything's fine. Or I just pop into the... Right. So 0, 2... Register 2 has a 1 in it. That's pushed. And register 1 has a 0 in it. That's also pushed. And then we jump to move. Right, and we're all the way up here. That's fine. So register 0, check, has a 0. That goes to there. Okay. Where are we now? There's a 0, still got a 0 in it. It's fine, I suppose. Retrieving our registers. Okay, fine. Highest disk is 3. Then we go to move disk. So magnet to source. That's bad. I don't like it. Why is source 3? Oh no, source is 0. Ugh. Highest disk is 3. And destination in register 2 is 2. So that's just going to go baboom. It's going to boom it up. It's going to be bad. Alright. Clearly, I have skanked up the algorithm somehow. Right. So, disk number, source, destination, and spare. Disk, source, destination, and spare. Disk, source, destination, and spare. Into registers 0, 1, 2, and 3. So that's just highest disk. That's fine. If highest disk is 0, move that disk. Move the disk. Move to source. Register 1. Turn the magnet on. Move to destination. Magnet off. Cool. Don't care about what's the spare. Don't care about the highest value. Save our registers. Push 0, 1, 2, and 3. Push, 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 push. Function call. Set this as our return address. Subtract 1 from register 0 and push it to the stack value. Add 0. Oh no, subtract 1 from register 0. For fuck's sake, I'm going to just. Right. Yeah, so. Sub. RI 0, 1, 4. Add IR 0, 4. Highest disk. We're going to do it again down here. Retrieve registers. And right. Don't know what's going on here. Try again. Save our registers. Make one less disk. Push that. Highest disk. Source, spare, destination. Right. Retrieve registration. Yeah. Highest disk. Spare, destination, source. What are you saving them from? A bad fish pie? A 3-week-old unrefrigerated pie, specifically. Dumb ways to die. Such is ever the way. Right. So in theory, I should not be pulling this. Right, let's just try this again. Function call. Initially, move disk from source to destination. Nice. Subtract 1 from, yeah, save the registers. Subtract 1 from the registers. Actually, I've saved them. I can put that in there, and then I don't need to use register 4. Retrieve them. Highest disk. Spare destination source. If this is correct, we should be onto a winner. Might not be, of course. Right. Click, click, click. So many clickety clicks. Right. So, I've done that. So we should now return to wherever we came from. So that should actually return all the way back to this call here, which is line 90. Yeah, all right. Which it does. Spare destination source and highest. Right, highest is 1. And then it says move disk again. And it drops it on the spare place, which is good. And then we come back to here. And we go subtract. So that's 0. And then we put that to there, which is cool. Right. And then we should drop all the way back up to, I don't know actually. Right, yeah, looks good. Right, so what I'm hoping for is that source is 0, destination is 1, and spare is 2. Right. So, source is 0, good. Destination is 1, spare is 2, highest disk is 2, correct. So you drop that there. Nice. And then we come back into here. We'll do the next function call. Whoa, we're getting a raid from Waylander Tone. Hello, Tone. You get the raid. We pop the raid shades. We do that. How you doing there, Tone? Having a good stream, I hope. Bang, what you been doing? Shadows. Ooh, 9 years of Shadows. Dude, you've been playing that a while. 9 years? God, you must be tired. Oh, looks all combination-y as well. Tick, 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 tick. What went on with that? Sounds interesting. Do tell. Lovely Raiders, hello, welcome in. I am Duke Euphoria Degrin, RGB, KSC, Night of the Living Dead, and Transgalactic Megapope of Rotating Space. We are today playing Turing Complete, in which we have designed our own computer mabob using wires and registers and NAND gates and swearing. The swearing. Oh my god, the swearing. We are now at the point of trying to run some relatively simple, albeit hideously convoluted assembly language on our shiny new computer, what we have invented. Yeah, could be worse. Probably could be worse. Not entirely sure how, but we're going to work it out. All right, so we have subtracted 1 from our call here. Oh, hang on. I need to move this around a bit so I can get to the knobs and buttons again. And our highest disk is now on 1. So, do I like these brain games? Yeah, I do a bit. They melt my head, and every so often I do just pretty much want to rage quit. But they do exercise my intellectual capacity, which I do enjoy every so often. Right, so we jump to move. Up we go to here. We pop our registers back into their setup. Our highest disk is 1, which means we aren't going to move a disk just yet. We're going to call down, save our registers, subtract 1 from our highest disk, and then set up for the next call. Source in register 1 is pile 2. Interesting. Destination in register 2. Hang on. We're pushing this in an interesting order. We're pushing source, spare, and dest. So what we actually really want to do at this point is move from 2 to 1, I think. I think that's what's going to happen. Waylander Tone says he likes puzzle games. Couldn't do these ones. Nah, some people do just, yeah, find their head melting hideously, which is legit at times. My head is having a bit of a moment, it must be said. Right, so source is in register 1, pile 2. Destination is in register 2, pile 0. Okay, I can see that. So we're going to move that disk to there. We then want to move this disk to here, then that disk back to here. So we're going to do that. All right, there we are. Right. Okay. Good. So dropping down again, dropping down again. Okay, nice. Alrighty. So we've now moved all the way up to 3. So we've got a lot of stack work to do before it gets back down to start moving a thing. So that should move number 1 to 0. And then pick up 0, put it on there, pick up number 2, put it on 3, pick up 0, more stack work. Okay, 1, hemina. Okay, I think the algorithm is now correct. So I'm just going to run it. Hemina. Chunk. Blimey. Woohoo, alrighty. Holy badgers. Right, there has got to be a way of doing this nicer. And there is a way of doing it nicer, absolutely. Oof. And right now I'm saving and restoring 4 registers. I only really need to save and restore maybe 1. But fuck it. Right now, I'm willing to work with that as is. Holy crap. So just for the sheer heck of it, let's zoom out. You see, this is our little computers doing its thing. Ones and zeros, ons and offs, little green arrows, a bit of program counter going chunk, 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 running code back and forth. And it doesn't even take into account the more functional blocks that are hidden away, like the comparator and the arithmetic logic unit. Oh, hang on. Somebody sent a message. Heinz Gustav. Hello today. How are you? It's pretty amazing. And if you want to learn how a computer works, I mean, really, very seriously, how a computer works, this is a good piece of kit. It will teach you how the machine runs from the ones and zeros upwards. I mean, okay, we managed that. Oh, thank God for that. We start all the way down the bottom. I mean, really all the way down the bottom with, as I have just demonstrated a few times before, the simplest piece of computer architecture, the wire. Oh yes, the wire, in which if you put a signal in at one end, it comes out at the other. Whoa, heavy, heavy shit. And then you go through various things. You make an AND gate, and you make an OR NOR gate, and then you make an OR gate out of NAND gates, and you inverts, and then you start doing fun things like, what's this one? Basic logic. Okay, an XOR gate hooked up together like that. Look at that. Nice. It's not the most efficient way of doing it, but here we go. Here's one. Boom. All right. This one counts whether there are an odd number of signals coming in. Oh yes. Basic Minecraft, says Finnan. Basic Minecraft? Well then. Let's go up a little further, shall we? An arithmetic engine. Look at that. What does this one do? This one does ands and ors and things. And, or, NAND, NOR, and AND, the 2 bytes together. So we've got 1 OR gate in the middle, 3 inverters, and some choices of yes or no. And it does us and, or, NAND, and NOR at the same time. It's clever. A bit clever. Laughing at my own jokes at that point. And by now, we have a thing. What does this one do? Yeah, we've got divisions and the multiplying. So there's a bit of hardware that does multiplies for you. It's not particularly tricky, but, you know, whatever. Do it. Finnan says, fun things with gates long before they invented redstone wire. Hang on a minute. You used the redstone powder on the blocks. Oh, God, yeah, I saw that. Yeah, I tried peeing around with Minecraft on that, and I just could not. I couldn't work out what the heck was going on because I couldn't work out where my redstone signal was going. Have I ever thought of working for NASA? Yes, I have thought of working for NASA. But right now I'm doing brain surgery rather than rocket science. So if NASA ever wave a flag in my general direction and say, fancy a bit of rocket science, I might be like, yeah, no problem. I can always ask a chum. I mean, I know a wee lass who works for NASA. She's lovely. In fact, I might even see if I can find a link so that you guys can say, go and speak to her later. She's not online at the moment. She's a streamer. Couple of downsides in that the poor lass does not do the speaking with the words after some hideous damage. But yeah, NASA, lovely chum. Right, okay, we have just done the dancing machine, which required us to write a program that generated random numbers. It was incredibly short. Yeah, there's our actual random number generator loop. Not particularly heavy. They gave us the algorithm. And we can just play it. Look at this. Let's get the dancing robot in there. Random dancing robot. Yeah. And once more, you can see all the numbers kicking off, doing fun things, causing fuss and bother. The hotlines going on and off when it decides to write to the program counter for jumping back and forth. Instructions kicking through different registers. It's joyful if you're me. Oh, I'll do my best, Dota. What kind of surprise would you like? Shall I turn up at your house with donuts? Would that be surprising enough? Surprise, yeah. Donuts are always cool. Okay, I think that's enough of that. We'll stop that. And right, the last challenge. Last one. Water World. Was this inspired by the dancing solar panels in Stationeers? Delethea, not so much. It's actually one of the tests in the game itself. It wanted us to build a random number generator to drive their little funky robot. I like the random numbers of the dancing solar panels because, frankly, they're one of the few things in Stationeers that you can actually control the angles of. I'm really hoping they're going to give us something like searchlights or laser beams or something. Because, you know, if you've got a trader coming in to land and you can focus some searchlights on them, that'd be pretty cool. Last one so far. Uh-oh. Oh, you reckon if I unlock this, it's just going to go, blah, you can do anything you like now. Let's find out. Good news, everyone. We want to turn the Earth into an exotic water park. It's not great news, Mr. Cucumber Head. It's not one of the best bits of news I've ever had. Fine. All right, exotic water park. See, half the premise of this is they're trying to determine whether I am a sentient being by being able to pass all their little tests. I've been abducted by aliens, you see. We need to help to find a good location for the Pirate's Plunge water slide. Specifically, we're looking for an area that can hold a high volume of water. Oh, volumes. Volume says multiply. Multiply says oh. Oh dear. Giving them a head start on the water world, yeah. Although if it has Kevin Costner in, I'm out. Sorry. As films go, the tedium was palpable. It was really a bit wet. And I'm not even sorry. Right. The landscape is 16 columns wide. Okay. Read the input 16 times to get the height of the landscape at each column. All right, I see where I'm going. Okay. All right. From left to right. Bum, 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 bum. Output the total volume that the landscape can carry as the answer. Wow. Okay. Right. Right. Apparently, Dota, it is indeed going to be an amusement park. They're going to turn the entire Earth into an amusement park. And, yeah, that'll be cool. Or not. Landscape is 16 columns wide. All right, I can do that. Get the height of the landscape at each column from left to right. I can do that too. Output the total volume the landscape can carry as the answer. Oh, well, I've got a couple of assumptions to make. Do the edges hold water? Because if not, we got, that's just going to spill. Oh, hit enter to show the water. All right, I'm hitting enter. Bok. Ah, the edges do not hold water. Excellent. Excellent. Right. So, is the water exotic? Freshly sourced from distant galaxies and freely losing and gaining electrons? I don't know. And it could be heavy. I mean, I'm reckoning it's pretty heavy. So what do we got here? 1 square, 2 square, 3 square, 4 square, 5 square. And here. 2 square. Right. So, how do I determine? Maybe it just tells me. No, it doesn't. Right. Total volume 28. So essentially all of those numbers added together. The edges don't hold water. Cool. LTO tape libraries are kind of cool. What's an LTO tape library, Night Dweller? And a tape library I can dig, but an LTO, I'm very bad at acronyms. I'm really bad. Also expensive. Keeping tabs on the second-hand market. 1 unit popping up for 678 slot tape library. 678 slots for a tape library. Wow. That's quite a lot of tapes. And that's a heck of a lot of tapes. All right. So, I've got a series of heights. Notionally, I want to say if the heights on the left and right are greater than the height of where I am currently at, I want to add 1 to the dots. Longer tape options, not a serious answer. A serious. Oh, linear tape open. All right. Wow. See, there's so many things that could be a large transferable object. Latex tarpaulin overhead. I mean, who knows? It's an open standard for tape drives. Okay. Nom. Okay. So basically, I am seeing a vertical grab of data and then a kind of horizontal scan with a kind of innie and outie concept. So I would start somewhere. Top down or bottom up? What do you reckon? Does it matter? Yes, because I have heights. So if I start bottom up, long tango oscillation. Ah, yeah. The mamushka. Right. So I read 16 values, put them in RAM. Pop, 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 pop. I'll run a loop with a notional height and an innie and an outie concept. And I start with the idea that I am an outie. So I need to go in, and whilst I am in, I add a dot. And then when I am out again, I stop adding dots. Out, 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 out. In a dot. Out. No dot. In a dot. out, 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 in, out, 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 in, out, out, in, out, out, in, out, 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 ew, in, but. Aha! Right, I only add the dots when I go from out to in and then back again to out on the same line. So I need an enclosed. So a ticky box that says, yeah, I started well. And then I have an interim additional gubbins. Wow. Okay. Interesting, because it's the cheapest option for storing digital data, in terms of like what pennies per gigabyte or something. Downside, the high initial cost for purchasing the hardware. Yeah. Well, people say never underestimate the bandwidth of a van full of tapes. Although these days, it's more like never underestimate the van full of really useful boxes full of micro SD cards. Those things are insane. I mean, they're absolutely mental. Right. Okay, I think I have a plan. This is going to be a bugger to write, but hey, that's just usual for this kind of thing. Previous program. Steal that lot, because that's my template. That's my useful shizzle. Bog. You bugger off, cucumber head. I don't like you. You smell. A nod of cucumbers. Okay. So, label. Input loop. Label with the lowercase l. Right. Add immediate 00 RAM pointer. I seem to be doing everything with like sneaky ads. But hey, that seems to work. 678 slot library would use LTO2 tapes, which store 200 gigabytes each. 135,600 gigabytes, so 135 terabytes. So, that's not bad. Delethea, what makes a box any more useful than a bog standard box? In which case, I suggest you Google or search on your chosen search engine the phrase really useful box. Other boxes are available. It's a brand name for some really quite butch and very useful boxes. Super in a number of ways. Aliana says, have a micro SD card that's approximately the size of your thumbnail that has many zeros times the memory of your BBC Micro. Yes. Yeah. When I tell people that I've worked with machines that had 1K and commercially useful machines that had 1K of RAM, consoles that were sold with 128K of RAM as like, my God, this is awesome. And yeah, written software on a 32K beeb, because why the hell not? I did a thing a little while ago, live journal, back in the day where people, were those kind of people and Facebook hadn't been invented yet, had the ability to put user icons. Lots of little people see user icons, but the RAM limit, the memory limit on their user icon was 40 kilobytes, 100 pixels square, 40K, which with a little shenanigans allowed an animated GIF of the tape version of Elite, which would fit into 32K on the BBC Micro as ones and zeros. So little hashy, staticky looking dots, and still had enough room left for a very tiny title page. People didn't understand, but you know, if they downloaded the GIF and decoded the ones and zeros, fed it into a BBC Micro, it probably would have crashed immediately because I'd made a mistake, but the idea was right. Yeah. Currently LTO 9, which stores what? Hang on. 18 terabytes per tape. That's ridiculous. That is ridiculous. And what are you going to do with 18 terabytes, 12 petabytes of storage? That's enough to store, you know, I don't even know what I'd store with 12 petabytes of storage. The atomic positions and spins of every atom in a large block of stuff. Are you trying to make some kind of transporter buffers here? Is that what it is? You're actually looking for matter transmission? Aliana, DNA molecule is distressingly, hideously low in storage compared to petabytes. Let's have a look at some numbers here. Where are we at? Data size of DNA. Human DNA, let's go with that. Human DNA. The male nuclear diplogenome extends for 62 gigabase pairs. How many gigabytes of data in human DNA? About 1.5. Even then, oh yeah, a really big DNA molecule, a massive one. 1.5 gig to store a person in terms of DNA. Because of course you only need 2 bits per base pair. Blimey. So if you're doing your proper human genome project, my little fella here can store 20 people on it. That's, yeah, I'd have some spare for pictures. Yeah. So, 1.5 gigabytes, all right, times 7 billion, give or take. So let's go 10 billion, because it's easier that way. So, a billion, 9 zeros. So, you need gigabytes, terabytes, was it... Oh, yeah, terabytes, petabytes. Oh, blimey. Yeah, I've lost. Was it Yotta next? Octa? I don't know. Mr. Ray, this just stores 1.5 gigabytes for just the DNA. 15 exabytes for the entire human race. So, yeah, Dweller, you get 10 of those little boxes of yours. 10 of those boxes? No. 1,000 boxes. 100 million, 12, 17.3, I don't know. A fair number of boxes. We could DNA up the entire human race, archive everybody off, let the planet lay fallow for a couple of thousand years, get its act together again, reconstitute all the humans. Of course, you'd be lacking things like memory. It's a bit of a bugger. Alright, tell you what, let's stick more storage boxes in there. Yeah, download everybody's memories. Give them a little thingy that sticks to the side of their head as soon as they wake up and are born, and it records everything they see, hear, and feel. Yeah, it's doable. It's not a great idea, but it's doable. Yeah, just storing the DNA, Mr. Ray. Just storing the DNA. Be fine. Ooh, 20 years ago they reckoned the internet was passing 10 petabytes, and now you could store that in your living room. I take it you can store that box in your living room, and it's not like the size of a massive cow or anything. Okay, what am I doing? I'm reading 16 lines of input. La 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 la. Add immediate value. No, yes, add immediate value to register. Immediate value to immediate value. A minute there. Add immediate value of 0 to my input register and store it in my RAM value. RAM val. Add an immediate value to a register, because that's when we're happening, to a RAM pointer. Branch if less than a register immediate RAM pointer 16, because that's the number of things we're reading. Branch, if we've got less than 16 to input loop. Yay. Okay, so now we have a bunch of values ranging from 1, 2, 3, 4, up to about 10 or so. Fine. Sure. La 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 la. Zero. Is that a 0? Don't know. 1, 2, 3, 4. I'd expect that to be 4. Let's find out. Ponk. I've read it straight into my RAM, which is this block here, and 4 it is. So 4, that should be 6. Oh. That didn't work. What's RAM pointer? RAM in a 5. Where's in a 5? And oops. Yep, alright, badly formed instruction. Better. Boop. 6, 1. Right, okay, so now we've got numbers. Bit of research. The Enterprise 1701D has the memory capacity to store the DNA of the entire human race 200 times over. Useful. Handy bit of kit. Turn up at a new planet, say, excuse me, dears, we've got an entire human race to download. We're off to the next planet along the line. See you in a bit. Right. 1, 4, 1, 2, 6, 5, 6, 0, 1, 4, 2, and that's the last one. Brilliant. So it should drop off the end of the loop, which it does. Excellent. So, right. What do I need to store? I need to store my notional height. I need to store my notional width. So that's 2 registers. I need my inniness and my outiness. And I need to have a counter. Width, height, flaggy gubbins, counter, and total. Right, so the total, I can keep the total in RAM somewhere, because I don't need all of that when I'm... Oof, no, I'm going to have a laugh with this. Right. Does the mushroom count towards height? 1, 2, 3, 4. I don't think it does. 4. 1, 2, 3, 4. The mushroom does not count towards height. Okay. No wonder the binars wanted it. Yeah, they'd be sitting there going, data me up. How much data can data store? Whoa, that's getting a bit self-referential. Okay. So, const. Height. We can put that in register 0. width. Register 1. Ooh. What am I saying is that the water will be horrendous to the local fungi population. Yeah, afraid so. I reckon it's going to mess up the plants as well. I reckon that bit of grass right there is doomed. Absolutely doomed. Terrible plan. Ooh. I can get away with an inniness and an outiness because I can use the sign bit of my counter and register 2. Width, height, count, and total in register 3. Alrighty, I've even possibly got room to do this. 16 across. Put a thing in here. Max width 16. Alrighty, now we're doing this. We're making it all readable for humans. Whoa. Alrighty. 4. Add II 0 to height. Label. Hat loop. And we start our total at 0 as well. Frankly, I'm finding this a lot easier than the recursive madness of last time. It's a pure iterative process, just a straight 2D scan. Okay. Width loop. Width. And, okay. Add II -1 to 0 to count. Right, we're starting this at -1. Minus means out. Alright. Can I do that? Probably, because I can I negate something? Ooh, did I add that to the arithmetic logic unit? Can't remember. Let's go have a look. What's in my ALU? Swap schematic. Oh, that is the ALU. Neg. I did. No, I didn't. But I could subtract it from 0 and that would work. Okay. So I need to remember that I can go in and out and in and out across the whole gubbins, can't I? Actually, I don't need to care. If I hit the other side of something, I reset my counter and add it to the total. Yes, I do. Yes, I do. Alright, alright. Looking good. Right. No. That bit. Actually, you go away. You're in the wrong place. You should be there. Alright, cool. Oof. Is next program going to be about beard length progress on the Effect Improving Society? Well, Deletia, we've already done the studies on this. Those of us who have worked it out, beard length basically is +2 wisdom per inch. So the longer your beards, the wiser your people. Long beard, wise chum. Now, okay, there are some ladies out there, and I know what you're thinking already, and I stand by what I said. There is nothing stopping a lady having the longest, most luxuriant beard on the world. But you choose not to. I don't know why. And there's some lasses from the Middle East and Far East who've got some lovely beards. Why can't you Western lasses keep up? Come on. And it embarrasses me sometimes. I'm looking around and there's lovely, lovely people, but not a beard between them. And what am I supposed to do at that point? What am I supposed to do? +8 to wisdom. Yeah, do it. Yeah, you're probably actually going to get a positive wisdom bonus any minute now. It's about right. You want to watch out what gives +2 charisma per inch. Wow. That's some pretty heavy stuff going on there. Right. So, what we do now is we read... Actually, our width is our RAM pointer. Our width counter across. It really is. Yeah. So I'm even going to do that. I'm going to say width is RAM pointer. Nice. Yeah. So my RAM value is just straight there. I can just read it. I can compare to it because I've built as if my RAM is a register with a particular thing. Nice. So I can even do that and that and that and that and that. There we go. Okay. Looking good. Sure. Ooh. In the width loop, we start out. So, branch less than RI. BLT RI count register 0. If it's less than 0, we go to out. Label out. This is the in section. We'll do the out section first. If we are out, we can possibly be in. So what we do is we branch if less than register. If our height register now, if our RAM value is less than our height register, we say go in. Label go in. What if they're equal? It still works. Have I got a BLE? Yeah, I'll use BLE and do it the other way around. BLE RR. X block. Right. At which point we add immediate to register. We add 1 to our width and we leave it in width. And if our width is less than our max width, we go to our width loop. Nice. Now we also have to define height, max height. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a 10? 10 maybe? I don't know. Right. Max height. Alrighty. And a back end here. Height. 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 Max height. To height loop. And then add IR0 total to out. Cool. Result. Okay. So these bits here to do and to do. Right. So if the count is less than 0, we go to out, where we are out. If it is less than, if the height is less than the RAM value, then we go to our next block, which is done. If the height is less than or equal to the RAM value, less than or equal to the, don't know whether I blarg. The height is less than or equal to the RAM value. It might just be less than the RAM value. Let's try that. Doesn't matter either way, we just change it. Then first off, we have been out and we are going in. So count, add II count 0, 0, set count to 0. And then drop to the next block. What do we set count to 1? We set count to 1, don't we? Alrighty. If we are in, right, if we do this the other way around, if the RAM val is less than the height, we never go straight to the next block. So we're in. Are we about to go out? Maybe I'll go out. Add IR count 0 count total and go out and then jump to the next block. Otherwise, add 1 to count and store it in count. Fun times ahead. Wow. Right. Is there an encyclopedia for the commands in this game? Oh, render. Right. Unfortunately, the encyclopedia is basically, I invented the commands in this game. So all of these, AND-RR, BQRI, are the names I have given to the opcodes that drive my computer. You can call yours Fred and George if you like. If that would make your head feel better, go to. Seriously, if you want to learn how the machine works, get the game. It will melt your brain. I make no bones about this. There will be points where you're like, oh. And yeah, it'll be like, my head fell off. Ouch. Other times, it'll be fine. Totally fine. Totally fine. Not fine. Right. So, with this piece of hideous spaghetti... my main problem here is remembering which way around my less thans and equals go. That'd be fun. Fuck it. Let's do the thing. Right. Shibbity-doo, shabbity, 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 shoo. Alright. Chunk, 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 chunk. Oh, it's the stack. I don't want any of that. This is what I want. Nim, 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 nim. You can move just across a little bit. You can move down there so I can see all the numbers. Can make games or other programs within this game. You really can. There's a sandbox mode which provides you with display screens, sort of akin to this fella here. You've got to set them up, but you could make Space Invaders if you wanted to. It would be a breathtakingly insane way of inventing your own game. If you want to program a game to play, you want to play Space Invaders, then this is not the toy for you. You want a copy of Unity or something like that. If you want to learn how the very low-level inner workings of a computer work with the wires and the ones and zeros, this is your bunny. Hell, even Stationeers would be a better place to learn programming than this. Because right now, let's give it an equivalent. It's like learning to build a house by starting with mud. And learning to build mud bricks, and then learning to build a kiln, and then learning to bake your bricks, and then learning to go out and dig the copper to make the pipes to make to have a bathroom, and then at the back end of it you're sitting there going, well, I'm going to have a bath now. Whereas the alternatives are things like nipping down the plumbing shop. So yeah, if you want to write your own games, this isn't your toy. This is a toy for learning how computers work and then melting your own skull. Alrighty, we've fallen off the end. Height is 0. Total is 0. Height loop. Width is 0. So, yep. And my count is 255. Alright, let's hope this all works. Right. Branch less than RI0 count to out. So this should drop down to here immediately. Oh. Yeah, it didn't work. Okay. BLTRI. That did not work. Why did that not work? As an unsigned compare? Can I not use minus 255 as a ticky box? Looks that way. All right. All right. So I'm working all unsigned. Fine. I could move this all around. Oh, wait. BQ. Have I got BQ? BQ. I'll just change it. Because I'm super lazy at this point. Right. Try that again. So we can put a breakpoint. We can do that. And we can run it to the breakpoint. Zop, 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 zop. There we go. Minus 255. That's not a byte. Correct. It's a pain in the trousers. That's what it is. All right. Okay. So BQRI 255 is out. And that jumps down to there. So height, which is in register 0, is indeed 0. That's the bottom of the line here. And my RAM value, which is in a register 8. Register 8. Ooh. Oh, I know, right? That should be 4. Oh, hang on. No, maybe it is 4. Yeah, a lot of 4s going on there. All right, so that's my device. That's got my RAM address in it. Yes, fine. It's some bollocksed up gubbins in there. All right, so RAM value is 4. So branch less than, so 0 is less than 4. It should go straight to next block, which it does. And adds 1 to the width, which adds 1 to my RAM pointer, and onwards and upwards. So it should just scamper all the way across here without adding a single thing to my total. All right. And then we fall off the end. Do we fall off the? We fall off the end in a bit. There we go. We add 1 to the height. And then we go back to height loop, which is up there, where we 0 the width, make the count 255, and onwards we go. If the count is 255, we go to next block. The count is currently 255. Oh, hang on. Oof. 4, 6. All right, now count is 255, but the RAM value on this one, is 1. Right, label out, branch height is 1, RAM value is also 1. So they are equal, so it should not jump to next block. It should add 1 to the count. Da da da! Yeah, I'm having to work all unsigned because I don't think I've done my ALU quite right. I think I've got a problem with that. I have to see if I can work it out. Okay, count. What did I put? Register 2 is count. There it is. All right. How am I going to get to recognize that the third last column can store 3 water? This fella here. Right, so what it does, it goes across, so it starts off in a what I've called an out state. And as soon as the height value is less than my scan height, it says, oh, there's a water dot there. But it only adds it to the total when it hits another non-low block. So it's going to come in here and say, like, my height is a scan of 1. So I'm full of rocks. I'm not full of rocks. Add a count. I am full of rocks again. Add 1 to the total. So it's basically zipping across sideways, going, if I've got an out, an in, and then another out, I win. I've got a minor concern that I should be starting on 0 rather than 255, but that'll show up here. I'll find out in a second. You see how I'm doing it, Aliana? Did I make sense? I wish I could actually... Oof. See, I could store the numbers. I could put them in RAM. Probably did, but your brain is doing a tired. Okay, right. Notionally, I'm starting here and I'm zipping across. So essentially counting holes. So I zip across, say solid, solid, a hole. And now it's solid, so I add that to the total. Solid, solid, solid. A hole, make a 1. Oh, it's solid again, add that to the total. And go back to solid. Oh, a hole, add 1. Solid again, add it to the total. So when I get here, it's going to go like solid. Oh, a hole. Oh, but I've run off the end. Yeah. I get here, it'll go solid 2, 3, 4, 5, but I've run off the end. So I think, yeah. See, I think. I might want to shenaniganize this a bit and start off on 0, meaning I haven't started yet. Yeah, so if I start off on an out, this is going to go in, shall we say, on width 0. Go out. Yeah, it'll add 1 to the count, and then it'll go to the next block, and it'll go, yeah, it'll get awfully confused. That's what it will. Brain's pretty tired, Process Semi-Prime. Wondering about sections where there is water on one side. Yeah. What, like the right, if I hit that, it shows that the edges here, the exit edges don't have water, and the entrance edges don't have water either. So, what do I need to do? I need to add that to there. If we are on a 0, we are on out. It goes to 0 again. So this only works when we are out. We had 1 here, so I've got to be a little careful at this point. But we don't start counting until we've hit this fella. Yeah, there's definitely shenanigans going on here. So let's pop that back to where it was. So I come in right at the beginning. First thing here, my count is 255, signaling that I am out. Whereas I actually, when I'm solid rock, shall we say solid? Okay. Well, I'm not really. I want to be counting this as hollow, but I don't want to be adding that on unless I've already counted a solid beforehand. Very tricky. Not very tricky, but a little tricky, you know. Right. So we can start confused. Got to be even more jumps and up knees and down knees. Oh dear, oh dear. Oh man, it's twisting my melon. Okay. So I could count both solid and what's name? Solid and empty since the last gubbins. And only if my solids are greater than 0. Alright, I've got a spare register. I've got a couple of spare registers actually. So let's call that solid. Right. And call that water. We're going to change all of this. Water. Solid. All right. So if we haven't had any solid yet, we must be on the outside. If solid is 0, we haven't started yet. Nah, that's nonsense. That's nonsense. Wow, lost my brain. Absolutely lost my brain here. Right. Okay. Branch less than register immediate solid BQ. Let's go with that. BQ. Skip count. Otherwise, so here, pos water. Label skip count. No, it's actually going to be next block, isn't it? Add one to water. Right. Bin all of this like this, just nonsense from here on in. Right. And then next block. Label rock. Add one to solid. Nice. And drop through to the next block. All right. Add register. Oh, no. Add IR 0 to water, leave it in total. Add one to solid. And add immediate. Ooh. Zero water. All right. Okay, so let's try this. If the RAM value, which is the height of the spike, is less than or equal to the height we are scanning, it must be rock. If it is rock, then we add however much water we've got to our total, might be 0, add 1 to our solid line and make our water become 0. This is a little extraneous after the first time, but we don't really care. Then we go to our next block along. Right. So, we do not, right, if it is not rock, it might be water, but it can't be water unless we've already had a solid block. Okay, so if our solid count is 0, FBQRI, then we don't even count it. Otherwise, we add on 1 to our water and carry on to the next block. Now, this is counting our temporary water, because if we run off the end, we will never find another rock and add it to the total. Yes. Alrighty. Dish. Boff. Oh, okay, boff. Thud. Right, got some data. Width, 0. Water, 0. Solid, 0. Right. So, should be rock. It's not. BLERR RAM. Okay, so got that the wrong way round. Branch less than RAM val height rock. Try again. Oh, knobsticks. Didn't put the breakpoint back in. Right. So, height, which is in register 0, is 0. Our RAM value is... where was it? Oh, we've already moved on. Right. Well, our RAM value should have been 4. So we add our water, which is in register 2, 0, to our total. We add 1 to our solid in register 1, so dish. and then we carry on and 0 our water. Next block, please. Still rock. So at the back end of this, when we get to the end of this line, we should have 16 in solid, 0 in water, 0 in total. Okay. Solid 16. Nice. But nothing else. Alright. Back to the height loop. 0, 0, 0, 0. Right. First one, rock. Second one, rock. Third one should be water. What's our solid count? Our solid count is 2. So it is not 0, so it does not jump to the next block, and it adds 1 to our water value. Excellent. Right, and then jumps to the next block, which is rock. So it adds 1 to our total. Where do we leave the total? Left the total in register 3. So we've got 1 total so far. And 0 is the water. Rock again. Rock again. Rock again. Next one, third. Do we have some solid? Yes. Yes, we do. So we add 1 to our water. Nice. Next block is rock. So we add 1 to our total. We're just a 3. Hang on. We're just a 3. Is it 3? So total should be 2 now. Should be 2. Why are you not 2? What's going on? I have a confuse. Maybe I haven't actually got there yet. Okay, no, here we go. Right, fine. So add 1. All right. 2. No, still didn't do it. Add IR. What? I am a stupid head. Right. To water. Add 1 to water. Add 0 to water and put it in total. Add 1 to solid, leave it in solid. Have I got a badly formed line somewhere, I wonder? All right. Okay, we can go around again. So this should add up to 16. Right. Maybe I'm just confused. Solid is 1, water is 2. Total is 3. Right. So number 5 is my RAM pointer. 0, 1, 2. Next block width. And up here, one is not less than 1, so it should fall into the water. Spaloosh. Solid, register 1 is at 2, not equal to 0, so it should not go to the next block. Add IR water to water, so that's register 2 has a 1 in it, and then we jump to the next block. Thank you very much. Back to the width loop where we should find a rock. Add water to total. Register 3 is 1. Add 1 to solid. And make water become 0. Right. 3 more blocks along. 1. Oh no, 2 more blocks along. I don't know, somewhere around here. Where are we at? 5, 0, 1, 2, 3, 4, 5. So next block. This should be rock. It is. Add IR water to total. Oh dear, oh dear, look at that. Yes. Oh, that'll be the thing. Right. I need to add RR, don't I? I don't want to be adding water to total. I want to be adding water to total and storing it in total, not adding 0 to whatever my water was at that point. Ha! Well, knobsticks. Fine. So I've got add IR here. Add RR is basically opcode 0. Save that. Derp head. 3 values, not 2. Add water to total, store it in total. Right. Ooh. Boff. So we'll run the first line. We'll run the second line. The third line, I should have 1, 2, 3, 4 dots of water in my resultant. Four dots of water. Nice. Next line, 1, 2, 3, 4, 5 dots of water. So 9 at the back end. Nice. Okay, breakpoint out, run it. Chunking and chunking and grinding and grinding. So what thing do I put height in? I put height in register 0, so we're at 7. Staying at 28, 8, 9, 10. Oh, right. So we got the first one correct. One, 2, 3, 4. Yeah, okay. Sneaky one there. Look at that. That's a bit sneaky, isn't it? Zoom out a bit. Watch the computer do its little dance of death. I wish I could actually mark a marker to say water at this point. Wouldn't that be nice? It hasn't actually given me any powers to do that. Alright. I wonder what the maximum is. So 16... I don't know what the numbers are going to be on this one, but it's going to be huge, isn't it? Oh my god, there's 128 tests. Okay, we're going to pause and we're going to say run fast. Hamina, hamina. I reckon it's offhand, I'll say that's working. Wahoo! All right. Holy crap, have we run out? Dude, we've done the thing. Every damn one of them. Victory for the good guys. That's us, by the way. Yeah, finished it. Edge to edge. Where's my victory screen? Where's my you're free. We're not going to eat you anymore. Is that it? For my next trick, make Tetris. Dude. Tetris. Oh, man. Okay. Not today. I may have a ponder. I actually seen a YouTube video of somebody playing Tetris made in Turing Complete. It's got to be doable. I mean, all right, the sandbox has a bunch of toys in it. Oh my god, what even was I doing here? I was making a divider, wasn't I? Yeah, I was playing around making a divider. Right. So you got all manner of stuff. A console for text displays, a 6x8 dot matrix display, and a sprite display. I do not know what that does. Sandbox objects has a keyboard input, good start, and a timer and some network data. Wow! So time to make my own web server, huh? No. Yeah. A disappointing ending. Yeah, I'm pretty disappointed. No, well done. No, nothing. Just, yeah, you're finished. You're done now. Look, that's it. I did it. I wonder if there's any DLC or something. So, I should be just looking for the, the next level. Right. Okay, this divider is, I'm sure it's lovely. Can I just sort of delete it all and play with something else? Derp. You go away. IO display. Oh, how do you work there? Not you. I said display. Display. Sprite display. Hello. Tell us about yourself. What the hecking heck? Select file. I can put in a sprite of some kind. I make it eat PNGs. And then no request, load a sprite or set position on command type. Sprite ID position. Wait, what kind of position? And size. How do I encode a position? This is what, just 0 to 255. What? Manual. Information. Components. Sprite display. Oh, phew. Screen at 645 depicts a sprite display. Before using the sprite screen, you need to attach a sprite map, which is a PNG image containing all your sprites. Okay. Click on the component, set the sprite map in the component panel. Right. First input pin is the command type. Meaning of the next 3 pins depends on the command type as shown below. Sprite ID is always an 8-bit number. Oh, sorry. All other values, position and size, are pairs of 16-bit values. Ooh. Yeah, Dweller, I was expecting some sarcasm, some condescending shit from that guy. But where was he at? He wasn't there, man. He was just like rubbish. Pairs of 16-bit values. So no command, load sprite. Sprite ID, offset in image, size in image. Offset in image, size in image. Pairs of 16-bit values. Right. Set position, the X and Y coordinate of the loaded sprite. It's not really very helpful. Sprites are layered in order of their ID. To remove a layer, simply load a sprite with a width and height of 0. You're twisting my melon, mate. Google the game has an ending. Found this unrelated paper. Web mat something AC and meh. Ooh. Wow. NFMSW. I'm just wondering whether that just says it's not safe for work. What do we got in there, Blinkster? I'm not going to click the link until I've got half an idea of what it is. Especially since it's from Birmingham. I mean, anybody knows what Birmingham can happen. Yeah. Infinite versions of Minesweeper are Turing Complete. Yeah, I can see that. So providing a relatively butch logical proof that you can use Minesweeper on an infinite board to write software. Let's not say we did. Wow. Right. Okay. The meaning of the next 3 pins. So command type 0, 1. Zero, no request. 1, load sprite. Sprite ID, position, size. That doesn't make any sense. Doesn't make any sense at all. Right. Sprite ID is always an 8-bit number. Pairs of 16-bit values. So presumably, I don't actually feed in like position here and size there. I feed in offset in image, size in image. No, that doesn't make any sense because that would have to be a single 16-bit value. That is not helpful. In fact, that's frankly annoying. Adding an extra row and column, these letters are put nice next to each other. Small tileable screen. Oh my. Right. Okay, I'm less enamoured of the idea of writing Tetris on this thing unless I can work out what their bloody sprite display is all about, because then I might be able to write Tetris on it and it might be workable. As is, I think I might take my victory and call it a victory at that point. Ladies and gentlemen, boys and girls, I think offhand we have done a win. We've started with a wire. We worked out how NAND gate works. We started making half adders to add a couple of bits together. And then entire adders to get a carry flag out the back end. Bytes added together. Look at that. Oof. Railways everywhere. Bits split, full adders, output combiner. Lovely. Nice. Decoders. 3-bit decoder. Look at that. Is that mank or what? Is that really, really quite unpleasant? And gates with 3 inputs and a bunch of knots. There has got to be a better way of doing this. There really has. It's just... See, up here, I'd love a 3-input NOR gate, but I haven't got one. I could put a 3-input NAND gate with 3 knots on it. And However, at the top end of things, we built a working computer. There it is. That's our final architecture, because for some reason it wouldn't let us keep our intermediate architecture, our little crappy one. And we were still making hardware changes right up until the end by remembering to disable our input registers when we were using immediate values, which we really kind of should have done to start with. Learning to program. Oh, sorry. CPU architecture 2, which is what we started with there. Hardware, ROM for running a program, no RAM. Barely any ability to do comparisons. Learning how to build a stack object so that you could do pushes and pops. Learn how to do functions. And then the assembly language challenges, which culminate in the downright top fun here of counting the blobs of water in the world. Yeah. At least they could have later give us, like, you know, Space Invaders to play. Right, I reckon we win. I reckon today has been a victory on a number of levels. So, if I go here, do that, cough and choke, finish the last of my coffee, and we'll find somebody to raid into who is lovely and awesome. Who shall we discover today? Who shall we find? Sorry, I'm still coughing and choking. It's not what we want at all. Mr. Beard is playing Stormworks. Barbaric is playing New Survivor. Pinkberry playing Don't Get Caught by the Ghost. Boo Man. Oh, no, sorry. Reading the things, he's playing Project Zomboid is our Barbaric. That's better. Ah. And Ali the Bot is playing Dead by Daylight. My, oh my, oh my. I think we should go and see Mr. Beard, because Mr. Beard is awesome in a number of ways and has a fine and awesome beard. Let's go and do the thing. Unless anybody has any other suggestions. Who do you think we should go? Have anybody got any ideas as to where would be an awesome place to vanish to? Now's the time to mention it. Gunter, lovely to have you with us, dear chum. I'm going to be playing Shapes fairly soon because I'm rather enjoying it. It's quite a giggle. And I saw something a chum of mine did, Mog's Minis. She just sat and read a book. She sat and she read Terry Pratchett's she read The Night Watch, and it was good because it was the glorious 25th and we needed to know how they rise up. So I might do something like that. I might get Treasure Island or something, do a bit of pirate. What would you ring to that? Give me a thing, hit the Discord, tell me whether it's a good idea or just a bloody silly plan. Blinkster's liking the idea, that's a cool. Discord. Bop. All this Turing Complete gubbins is going to be on YouTube any minute now. So let's put a tube link in there as well. They're all on the page, but have I seen the game Plasma? Yes. Yes, I have. In fact, I think I might have it on the old wish list. I have to take a peek. Very much sandbox only, but looks interesting. Yeah, it's seriously early access, says memory. I mean, like really amazingly early access. So I'm going to hold off until they don't utterly ruin it by, adding tribbles or something. But there's a definite plan. Okay, right. What did we have? We were going to raid into Mr. Beard because we can. Raid. Bok. Mr. Beard playing Stormworks. Mr. Beard is a lovely fellow. He may be utterly stoned out of his gourd, but it's 100% legal where he is, so crack on. I will see you lovely chums later. Have a fine time. Chances are I'll be back here on Sunday doing Moon Unit stuff. Never know, might be here tomorrow. Slim chance. we're going to the Rocky Horror Show. Won't that be fun? See you all later. Have a lovely time. Catch you in a bit. Bye.